Solve distance, rate, time problems using two variables. Well, Van and Ivy's sample are planning a bicycle ride to raise money for cancer research. Van can ride 50 miles in the same amount of time that Ivy can ride 40. Determine both bicycles' rates if Van's rate is 2 miles per hour faster than Ivy's. So coming back to our drawing board, we know a couple things. Distance is equal to rate times time. So let's make a chart. We have Van and we have Ivy. So rate times distance. We know Van's rate is 2 miles per hour faster than Ivy's. So we have these x and y rates, but Van x is equal to Ivy's y plus 2. We also know Van traveled 50 miles and Ivy traveled 40, and they traveled it in the same amount of time. So the way to find time is, well, if we manipulate this equation for time, we get time is equal to distance divided by the rate. So if I take my distance column and divide it by the rate column, I'll get this column. So 50 divided by x gives you Van, and 40 divided by y gives you Ivy. And so, if I set those two things equal to each other, because they did it in the same amount of time, that's the key point. But we have two different variables. Well, wait, we know that x is equal to y plus 2. So I can plug that in here. So I get 50 over y plus 2 is equal to 40 over y. Cross multiplying, I get 50y equals 40y plus 80. Subtract 40y. 10y equals 80. Divide both sides by 10. And y equals 8 miles per hour. That is Ivy's rate. So if Van's going 2 miles per hour faster, Van's going 10 miles per hour. Those are two decent speeds for a bike. So a big thing to take around this, diagrams and pictures help a ton. Then we can pull equations out of them by stating what we know from the problem. And pay attention to keywords like in the same amount of time, or they travel the same distance. Things like that make it so you can make these type of equations.